Good morning, students. In today's video, we are going to cover this topic. Okay, so we have officially started a new chapter that is materials of the Earth's crust, rocks, and minerals. Okay, so we are gonna talk about the materials of the Earth crust. The crust we know, the uppermost layer. We will see like what is it made up of. Okay, in the previous chapter we have covered the topic isostasy. In that we have seen that how this crust adjusts itself, in this, but we isostasy doesn't explain that what is crust made up of. But in this particular chapter, we are going to see that what exactly crust is made up of. Okay, so let's see. So the Earth's crust is separated from the mantle. Okay, we know that Earth crust. So we have like three layers in the Earth's interior structure, internal structure, that is crust, mantle, and core. So these all are divided, okay, and these all are separated. How? Because of this discontinuity that we have covered earlier. I will explain you here as well, so don't worry. So this separation depends on the chemical composition, density, temperature, and minerals. So why does this separation occurs, like crust, mantle, core? Why there is not only one layer? Just because of the chemical composition, the density of the rocks that make those layers, the temperature. As we know, the temperature increases as we go down in the earth, and the minerals. Okay, the boundary between crust and mantle is called the Mohorovic discontinuity, discovered in 1909. So we can also say it as Moho discontinuity, which is the boundary between the crust and mantle. Okay, Moho marks the lower limit of the crust and upper mantle. Okay, so this discontinuity separates the lower limit or the lower part of the crust and the upper mantle. Types of the Earth's crust. So we will first be covering the concepts related to the Earth's crust. So Earth's crust is basically divided into two parts, that is continental crust and oceanic crust. Continental crust, as the name suggests, that this crust is made up of the continents and made up of heterogeneous materials. Okay, those continents are made up of heterogeneous materials. That means not homogeneous. So if you know is the difference between homogeneous and heterogeneous, so homogeneous like same type of material, okay, and heterogeneous different. So the crust, the continental crust is made up of heterogeneous materials. Include river basins, oceans, streams, lakes, etc. Thickness varies and can reach up to 75 kilometer under mountain regions. So the thickness is more under the mountain region, 75 kilometer. Why? As we all know, for mountains to build, we need two things: thick crust plus low density. Why low density? So that it can elevate more and at the same time get and at the same time has deep roots as well. So for that we need thick crust, but not the dense crust. Oceanic crust lies beneath the oceans, as the name suggests, denser and thinner than the continental crust, formed mainly at mid-oceanic ridges. So yes, these are like denser and thinner than the continental crust, means it is thin but it is heavy, dense, and it is formed mainly at, so where it is formed mainly by the mid oceanic ridges, These oceanic ridges are basically this these are like this, like the mountain like structure inside the oceans where the magma comes out of the mantle, and that creates the crust, oceanic crust. New crust is continuously created and spread outwards. So it creates the oceanic crust. The magma that is coming out of these mid-oceanic ridges create the continental crust. Conrad discontinuity. So this, as we have studied more discontinuity, so we have another discontinuity that separates the upper and the lower parts of the continental crust, and known as the Conrad discontinuity, located at the depth of about 15 to 20 kilometer, found only in continental regions, not in oceanic crust. Sorry. So these Conrad discontinuity separate the oceanic crust and the continental crust. Okay, oceanic crust and the continental crust, and it is not found under the oceanic crust, but rather it is found under the continental crust. Okay, and it separates the oceanic crust from the continental crust from the oceanic crust. Thickness and nature of crust. So average thickness of the earth crust is 35 to 40 kilometer. Crust is the uppermost and relatively rigid layer of earth. Acts like a shell over the earth. Together with the upper mantle, it forms the lithosphere. So basically, lithosphere contains what the crust and the upper parts of the mantle. Okay. So if I say lithosphere, so you have this picture in your mind. This definition, you can say. These two points should be in your mind, that it contains the crust and the upper parts of mantle. Formation of the earth crust. So earth was formed about 4 billion years ago. So it was formed about 4 billion years ago. Initially earth was in molten state. It's in the liquid state. Gradual cooling led to the formation of a solid outer layer called earth crust. So gradual cooling of the earth leads to the solid outer layer, that is the earth's crust. So think of it like this. Like if you have hot milk, when the hot milk gets cold, the there is a upper layer, means there is a layer formed on the milk. So you can think of it like this, that the earth was in molten state, it is very hot, but as it gets cold with time, upper layer started to form on it, and that upper layer is called the crust. Okay. Crust allowed the development of life forms, including the humans. Now we will second topic is the concept of the continental crust and oceanic crust. So we will cover them separately. Continental crust lies above mean sea level and support human life, settlement, agriculture, and fresh water. So these it began forming about 3.7 billion years ago due to the volcanic activity, and over thinner oceanic crust leading to the formation of continental sheets. So how does the continental sheets form? Basically, it began to form about 3.7 billion years ago due to the volcanic activity, from which f- uh, like these volcanic activities happened on the thinner oceanic crust, and this leads to the formation of continental sheets. Continental crust is made up of all three rock types. So these continental crust is made up of these three rocks, that is the igneous, sedimentary, and metamorphic rocks. And this we know these rocks are formed by the rock cycle. Okay, we have covered the rock cycle. What happens is that these igneous rocks, that these are formed from the cooling down of the magma that is come out of from the earth's internal interior parts, or you can say from the mantle, and then after cooling down it forms the igneous rocks. Igneous rocks get eroded and deposited and it forms the sedimentary rocks, and then the sedimentary rocks, when they experienced high heat and pressure, form the metamorphic rocks. Okay, this continuous transformation is called rock cycle. So continental crust is less than other Earth's layer, that is 2.7 gram per centimeter cube. Its main chemical composition is Cl, that is silica and aluminum. Continental crust floats over the dense mantle. Collision of continental plates form the mountains. So what happens is, when this particular continental crust meets this particular continental crust, when they collide, they rise, and you know, may they like make these depressions, or we can say, so these two deep roots at the same time. So they rise also, they make these deep roots as well when these two continental crust collides. The thickness of continental crust determines the height of mountains. So how high these mountains are going to form depends on the thickness of the continental crust present there. Greatest thickness of continental crust is found under the major mountain systems. Concept of the oceanic crust. So about 70% of the Earth's surface is covered by oceanic crust. It originates at mid-oceanic ridges due to the volcanic activity. We have just covered what are mid-oceanic ridges and how they form the oceanic crust. So oceanic crust spreads outwards, subducts into the mantle and melts. So what happens is, these oceanic crusts are formed from the mid-oceanic ridges, and then they spread, and then they meet this continental crust. Okay, continental crust is less denser than the oceanic crust, so when they meet, usually, most means every single time, we can say that oceanic crust, not every single time, maybe there are some exceptions, but we are not considering them right now. Let's go with most. So, what happens is, they collide. This is the oceanic crust, this is the continental crust, and this oceanic crust subducts. Okay, and this continental crust is upwards. Why? Oceanic crust is more denser. Its density is 3 gram per centimeter cube, uh, a cubic centimeter, or like continental crust density is 2.7. So you can see. And then it goes down, subducts, and sorry, and then melts. Means it goes down into the Earth's interior, and then there it melts because Earth's interior has high temperature. So it is younger than continental crust, generally less than 200 million years old. So 200 million years old, less than this, they are calling it younger. But that's how it is. Made mainly because this process takes long time. It's not like this that these mid-oceanic ridges form the oceanic crust and suddenly we see the oceanic crust everywhere and the subduction happens. This takes a lot of time, these processes. This oceanic crust is mainly made up of basalt rock, that is a volcanic rock. That means the basalt rock is formed from the magma, and the materials, lava, magma that comes out of the volcanoes, cooling down of them makes these basalt rock. Oceanic crust is denser and all. Primary P waves travel through it at the speed of 7 km per second. Main chemical composition is silica plus magnesium. Continental crust is made up of Cl, silica and aluminium, and oceanic crust, Sigma, silica plus magnesium. According to the plate tectonic theory, oceanic crust forms at divergent boundaries mid-ocean ridges. So, according to the plate tectonic theory, the oceanic crust these forms at the divergent boundaries. Divergent, like when they rise, and these are called the mid-oceanic ridges. From there, the oceanic crust is formed. Subducts and the convergent boundaries. So when it met, I have just taken an example. Convergent boundaries. Subducts happen mainly like you are going downward. You are subducting. Like sub means a sub is basically the part of something larger. Okay, that means something. This is the heading, and then we have subparts downwards. So you can connect it like this, that this subwards mean the downwards. So subduction happens. Uh, in subduction, the oceanic crust goes downwards, and these create the trenches, the volcanoes, and the island arcs. When oceanic crust collides with continental crust, the oceanic crust always subducts because it is denser. Yes, we have covered it as well. So today's homework is to create a flowchart on a rough paper explaining this concept. That's it for this video. Thanks for watching.